This is for the Trammel toy, the pin slider block. So in your kits you have two slider blocks. Both are green. One has a rounded edge right here, and one has a square right there. The one with the pin that will snap into it is called the pin slider block, and it is the one that is rounded over. It allows us to snap a pin into it from our Vex kit that we have. This plastic beam that goes across here, that is a Vex beam. Right there in the center of that is a blue snap pin. This is that snap pin right here. That snap pin gets pressed down into the top of this slider block, down through this hole. The hole is narrower at the top, and then it has a little lip, and it gets wider at the bottom. That is a counterbore hole coming up from the bottom, which creates that effect. What that allows is for the snap pin to slide down in, and this little flange area right here will snap out around that and be held in place inside of this hole by that lip. So let's go ahead and start to create this slider block. We need to go into our Fusion 360. If you have not already created a Trammel folder, a Trammel toy folder, you need to do that. Go ahead and create a new folder, Trammel toy, Trammel toy. That'll be the folder, and we're going to open that folder up and make sure that we are working inside of that and saving our items that we're going to make inside of this. So once I'm inside my Trammel toy folder, I'm going to go ahead and close that. And the first thing I'm going to do is save this document with my initials, your initials, and this will be pin slider block. Pin slider block. We'll save that. So we've got that saved up here. We need to go to the document settings, make sure we are in inches, which we are. And at this point, we're going to create a new component. And in order to create motion later, these have to be as components, not as bodies. So this component then will move within the combined when we do the assembly of the entire Trammel toy. So I'm going to go ahead and label this component as pin slider block. And I'll go ahead and click OK to that. And notice now that the pin slider block component is active because it has this dot in it. So, okay, now with that, let's go ahead and get started with our drawing. To make this 3D model, we're going to create a rectangle on our bottom view that is 1.75 inches long and 0.734 inches tall. So I'm going to go on the XZ plane, which is the bottom view. I'm going to click on Create Sketch, click on my bottom view XZ plane, and in doing so, I want to start by creating a rectangle. The rectangle is going to be 0.743 inches in height, 0.734 inches in height, and 1.75 inches in width. I'll go ahead and zoom in on that so I can see it a little better. And I'm going to create another rectangle for this inside area. These rectangles are clipped. We're going to use the chamfer tool and clip the edges off of them. So I'll create my next rectangle. When I make this rectangle, it's important that I get it to snap to the line. So do you see how I have an X showing up on there with that box? The box is allowing it to snap to the grid. The X is causing it to snap to the line. And I want it to snap to the line. So I want it to be coincidentally constrained to the line. And when I come over here to the other side, I just get an X. It doesn't give me those grid snaps for some reason. But that's okay. I want that X because I want this line to snap over here. It doesn't matter where I put those because I'm going to create some dimensions on here that are going to fix that. When I look at this object here, it says that the top lines are separated by 0.141 inches, and the same with the bottom. So I'm going to go to my dimension tool, click on the two top lines, drag out here to the right, click to place my dimension, and I'm going to change it to 0.141, which is what that dimension is. Going to do the same thing at the bottom with my dimension tool. Drag out here. I can either type in 0.141 or I can have them constrained to where they match each other by clicking on that original dimension, dimension 3, that's what the D3 stands for, that was the third dimension that I put in, and hitting enter. And notice it says FX 0.141, that means it's a formula. And that formula is saying that, hey, this is the same as that dimension there. So if I change my original dimension to anything else, it will automatically change this dimension and it will move with it. I'm going to give you an example. You don't need to do this, but I'm going to edit this dimension here and change it to 0.1 and watch what happens to both the top and the bottom lines. They both just changed, which is fine, to the 0.1 dimension. And if I want to put those back, I can just go back in here and change it back to 0.141. And they both just changed again. So those are connected to each other as we go through our drawing. Next, we're going to clip the corners off using the chamfer tool. The chamfer tool is under Modify, Chamfer, Equal Distance. The equal distance is down here, telling me on this third image that it's 0.125 for all the chamfers. So I'm going to go ahead now and click on this first corner. I get right on the corner where I get that dot, and I'm going to change that dimension to 0.125, and it moves that back. So it's right there at the edge. I'm going to click on the next dot. It'll do the same. It's still holding this dimension right now, which is what I want. I'll do the next dot or corner, next corner, and work my way around. Making sure I'm getting right in there on the corners. And at that point, I'll hit enter, and I've got all of them done. Looks a little messy because it put in all those 0.125s, but that's okay. We look pretty good with all of that. I'm going to go ahead and finish my sketch. Go to my home view because I like to work off of that. And I'm going to use my press pull tool to extrude these two areas up. And the dimension is not given on the drawing, but the dimension we need is 0.4 inches. And the reason for that is if I look at this drawing, this curve comes up to the top here and across this area, but they only give you the dimension from this corner right here to the base. All right. So where that intersection is right there is actually right there in that spot. And because of that, that's where the 0.375 comes in. Well, in order to get that with this round that we have of 0.25, this whole overall height needs to be 0.4. So I kind of saved a step because that was not given to us the way it should have been, so that'll help us out. So let's go ahead and round off these two corners here using our fillet tool. So I'll click on this corner and the one on the back edge. I lost this one. I need to click on it again. And it is 0.25 according to our drawing here. 0.25 is our radius. And that rounded those over, so I'm going to go ahead and click OK to that. And if I go in and turn my original sketch back on, because I'm going to need it, I've got to go into the component, which is my pin slider block, open my component up, and here are all my nested folders. And I'm going to open the sketches folder and turn on sketch 1. Now, if you notice, when sketch 1 turned on, I can now see the corner up here, or the intersection up here, and the intersection on the inside that's down here. Or I can go here and measure this line right here. Same thing, doesn't matter where it is. If I use my inspect tool and click on that line, it will tell me that it is 0.375 inches, which is exactly that length that they want that to be from where that connects right there to the base. So I could also do it from this point. Let me escape from that. I could do my inspect and go from this point right here down to that point right below it on the sketch. And again, you're getting that 0.375. So we know we have that correct now. So the next task is I got to extrude this middle section up. So I'm going to click on that portion with my press pull tool. Ooh, let's try that again. I missed that. And it's going to be extruded up. It says 0.813, so I'll type in 0.813, hit enter. And now I've got my part. I'm going to turn that sketch back off. My part that looks very similar to this right here, except for we're missing this hole. So we talked about holes in Unit 1 or Activity 131 or 132 at the beginning here before they told us to start building these parts. The hole is actually a counter bore, and the counter bore comes up from the bottom. So I'm going to switch over here by clicking on the bottom of this corner of my view cube so I can see the bottom. And now that I can see the bottom, I'm going to use the hole tool, and I'm going to click on the bottom surface, and it randomly placed it right there where I clicked. But that's not good enough for me because it's got to be, I need it to be in the center. So I'm going to click on that and start to drag it. And as I start to drag it, you'll notice a dot shows up. And that dot, conveniently, is the center of the whole base here, the whole bottom view. So I'm going to snap to that. If it didn't work, I can also dimension it into that center point. The hole I'm going to draw is a counter bore. That symbol right there on the left here means counter bore. It is counter bore. The counter bore is the large part at the top of the circle of the hole that is 0.177 inches in diameter. So over here under hole type, I need a counter bore, which is the middle one. Now I get some dimensions. This part is the counter bore, and it wants to know how far is the counter bore, what is its diameter. The diameter of the counter bore is 0.177. So I'm going to change that to 0.177. Then it says, how far down does the counter bore go? In this case, the counter bore, it says, goes down 0.633 inches. So I'm going to change that to 0.633. And then lastly, we're given that the rest of the hole, the remaining part, goes through all the way through, and it is 0.165. So this is a through hole. It means it goes all the way. So my extents are going to be a distance of all, which means this hole goes the whole way through. And then it says, what is the diameter of the remaining part of the hole? And I just said it was 0.165. So I'm going to change this to 0.165. And at that point, I'm going to hit OK. And it drew in my counter bore. Now, if I zoom in here, you'll see there are two different edges here. An edge here on the outside and an edge on the inside. That's the counter bore. Right now, there is a hole that goes down in 0.633 inches until it gets to that point, and then there's a flat ledge right there, and the rest of the hole is only 0.165 in diameter. So it starts out on the outside at 0.177, goes down 0.633 inches, and then it is the next hole is 0.165 the rest of the way through. So let's see what that looks like if I slightly move my view. There you can see it now. So this outer edge is wider, it's more open. Then there's a little lip, and then the remainder of the hole. And again, that lip is where the flange of that snap pin, when we push it down in, will snap around that edge. So at this point, I'm going to go to my home view. I'm going to save my drawing. And at that point, I want to make sure I take a snip of this and add that to my Google Doc. And that's it for the pin slider block.